Okay, uh, let's proceed to question 4. Okay, question 4. A particle of mass mkg moving through the A with a speed of v experience a resistance of magnitude of 0.004 mv squared. The particle is projected upwards from a point of O with a speed of 50 meter per second, and t seconds later it has attained a height of x meter. Show that while it's moving upwards, v and x are related by the equation 250 dv dx is equal to a negative 250 plus v squared. Okay. So for part A, uh, so for this question, if you refer to the resistance, I mean resistance magnitude, most probably in the Newton, the resistance force. Okay, so the resistance force depends on the velocity that at the moment, right? At the particular moment. Okay. V square mean maybe the traction is not important, so the speed is important, right? So we go for part A. For part A, we know that when you're going up, F equals to ma. Okay, the net force. Okay, so we can form a net force equation. The resistance is face down with the item going up. Okay, and don't forget mg also face down at the first place. And from here, you simplify, you will have A equal to negative 0.004 v squared plus 10. Right, so this is for the A. Right, so if you want to change this equation to the equation that stated in the question. Okay, so you may change the A become v dv dx. Okay, so if you have v dv dx, will be equal to negative 0.004 v squared plus 10. Okay, so question have a 250 multiply 250, and you will have a 2500 plus v squared. Alright, so this is for question A. So you will form an equation that required by the question. Okay. Okay. For A, for part A, still have a little bit. Okay, integrate this equation by separating the variables and show that the greatest height reached is approximate at this 7 meter. Find the exact value of this height. Okay, exact value of this height, right? So your final answer, you should put equal to 87 first, then maybe you can keep your final answer in the exact value. Okay, maybe for example in the sub form ln, or maybe in the fractional form. Okay. Okay, now we proceed to integrate the equation. Same thing, I put all the v in one side. So integrate, you can apply ln because the differential or lower part equal to 2v. So above you should change to 2v. So you have shift the 125 out, right? Then you have 2v above. Ln 2500 plus v square plus c. Then the behind you only have x, right? And you should put the initial condition when t equal to 0 and v equal to 50. Right, t equals 0, v equals to 50. So when you put it back, you should get and don't forget x equals 0 at the beginning. X equals 0 at the beginning. And when you put it back, okay, you should when you substitute to the equation, you should get c equal to 125 ln 5000. Okay, so put the c back, you will have x equal to negative 125 ln 2500 plus v squared and plus 125 ln 5000. Okay, so if you want to find the maximum height, v will be equal to 0. So sub v equals 0 inside, you will get x equal to ln 2 125. So if you further calculate, this will be almost equal to 87, right? So you prove the equation. So the exact value will be 125 ln 2 lah. Or if you don't want, you may put ln 2 power of 125, right? Depends on you, right? So the easy way will be 125 ln 2 lah, right? So this is for question A, the last part for A. Okay, so now we'll proceed to part B. Okay. Okay, for part B. Part B mentioned the particle now falls to the ground. Show that on its return journey, v and x are related to by the equation this. Integrate this equation by separating the variables and find the speed which is to the ground. Okay, so for this question, it's a return journey, but we still use the original direction is go up, right? Original direction is go up, so we go up will be positive, right? Okay, so for this question, okay, MA. So now the resistance is facing up. G is still down. So you have A equal to 0.004 V squared minus 10. Okay, so question have negative 250. So negative 250. Okay, and v dv dx, and behind also multiply negative 250. You have 2500 minus v squared, right? So this is for the differential equation for the part B. So in order to find the velocity that returns to the ground, so you need to integrate, right? So by separating by two sides, okay. Okay, so we start to integrate. So integrate, put all the V in one side. Okay, and you may apply loan. And the initial condition, okay, I mean at the maximum point, you know that t equal to, we calculate from the maximum point, okay, t equals 0, v equals 0, okay, and x equal to 0 also, right, we calculate at the maximum point. So by applying this initial condition, you should get c equal to 125 ln 2500. Okay, put it back to the original equation, you will get 125 ln 2500 minus v squared is equal to x plus 125 ln 2500. Okay, and you know that from the maximum to the ground, the distance that just now we have calculated is at least 7 meter. But now it's go to the ground. Okay, so from top to the ground means the x is equal to negative ln 2 125, right? Negative distance. We assume go out is a positive. Okay, so slightly back to the original equation. So you will have a equation that similar that 125 ln 2500 minus v squared is equal to negative 125 ln 2 plus 125 ln 2500. Okay, so you have this equation. Simplify, you may have ln 2500 minus v squared to minus ln 2 plus ln 2500. Okay, so simplify some more. You may get 2500 minus v squared is equal to 1250. Okay, and we deposit v squared will be equal to 1250. So v equal to square root 1250. So your v at the moment that touch on the ground will be about 35.4. Yeah, so it's a negative direction. Okay, so the magnitude is equal to 35.4 meter per second. Okay, so this is for part B. Right, for part C, it's still the particle has been dropped from a much greater height. What would be its maximum speed as it fell to the ground? Okay, so I'll use the equation that we formed just now. Put the ln in one side. So you may have loan x over 125. Okay, so you have a loan modulus 2500 minus v squared minus loan 2500 is equal to x over 125. Right, simplify some more. You have a 2500 minus v squared over 2500 is equal to ex 125. Right, so when you drop much more higher, mean you can expect x can be a negative infinity, very high, we don't know how high. Okay, so ex 125 will be a plus to 0, right? Like that you have studied before, so that you can simplify the equation that just now. So 2500 minus v square is equal to 0, and v square will be equal to 2500, so v will be equal to square root of 2500, so 50, right? So if you refer to this question, right, if the x is very high, and but at the end, after a long time, you have a v equal to 50, right? So v seems like become a constant. So this one you can call as terminal velocity, right? Terminal velocity, right? So the v won't increase after a certain point. Okay, so this is for question 4, right? After this, we will proceed to question 5. Thanks.